Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of intermolecular forces. What are intermolecular forces? Intermolecular forces are the attractive forces that hold particles together in the various phases, whether solid or liquid, the condensed phases, or the gaseous phase. The magnitude of the attraction between the two particles, or the magnitude of the IM forces, determines whether it's solid, liquid, or gas. The stronger the force, the more likely it'll be a solid. If it's an intermediate force, it'll be liquid, or very weak force, it'll be gaseous. If we are dealing with a pure substance, these forces collectively are termed van der Waals forces. They consist of London dispersion forces, the weakest force, dipole-dipole interactions, a stronger force, and a specific type of dipole-dipole, hydrogen bonding. We will discuss these at a later date. For now, let's refresh our memory on what a dipole is. Anytime we have a low electron negativity, let's say this blue sphere under this cloud is hydrogen, and this red sphere underneath here is a halogen. Halogens have much greater electronegativity than hydrogen. That means that in this bond, let's say hydrochloric acid, the electron density is a lot more over the chlorine or the halogen than it is the hydrogen. There's very low probability of finding the bonding electrons here. So as a result, there becomes a redistribution of charges, an asymmetry, or a polarization of the charges. The one that's got the higher electronegativity will have a partial negative sign, or a delta negative, and the one with lower electronegativity, since there's not that much electrodensity around it, it will be partially positive. So up until now, we've been looking at just the interaction with two particles or two elements within a molecule. The shorthand notation here is the plus sign goes with the partial positive charge, and the minus sign, or the partial negative charge, goes with the arrowhead. This is the shorthand notation. This is indicative of a dipole. So if you ever see that, you know they're talking about a dipole. So that's basically it for the introduction to intermolecular forces. Make sure you watch the individual videos for London dispersion forces. There's going to be another one for dipole-dipole interactions, one for hydrogen bonding, and then there's one not listed here called ion-dipole interactions. Collectively, they form the intermolecular forces. You should also take a look at ionic bonding. That's also an IM force. A lot stronger than these forces. If you think of most things that are ionically bonded, like table salt, they're solids at room temperature. That's indicative of a higher IM force than something like diatomic nitrogen, which is a gas at room temperature, or O2, which is also gaseous at room temperature. All right? So make sure you understand what the forces are. You should be able to look at a compound or a molecule and determine what forces are present, and then also be able to rank them if you were comparing different compounds. All right? So I hope I've clarified things for you, removed any doubts that you might have over the basic concept of intermolecular forces. Make sure you watch the example videos as well as the rest of the concept videos I just listed. Thank you and have a nice day.